We are going to learn about simple linear regression analysis in Excel. And one of the things before you do analysis, you need to identify what is your dependent variable and your independent variable. By simple, we mean we have one independent variable, and of course, we have the dependent variable in this case. And also remember, you make sure that you have already installed your data analysis toolpack, which is in Excel. If you've not installed, I will share the link within this video, whereby you're going to see how to install the data analysis toolpack. So what do we do? The first thing is, in this case, our closing stock is our dependent variable. This is the dependent variable, and current asset ratio is our independent variable. So we go to the data toolbar. So once you go to this toolbar here, you select data, and then you go to data analysis. In data analysis, you're going to find all these data analysis, all these tools. So once you get all these tools, the best thing you can do now, we have the regression, and then you click OK. When you have regression and then you click OK, you'll find that what is our input range. If our input range here, Y range, is the dependent variable. The dependent variable here is our closing stock. So you select the closing stock, and then the X range is the independent variable. In our case, the independent variable was what? Is the current asset ratio. So again, you select the current asset ratio. And then you come to these checkboxes here. These checkboxes here, remember we need to select labels. Why are you selecting the labels? We are selecting labels if our first row was the variable name. And in our case, the first row, that is the current asset ratio, and the closing stock are variable names. So these Excel identify these variable names as labels. So you have to select them. Otherwise, it will not be able to analyze your data. So in this case, let's say for example, and then let's say for example we didn't select these as labels, and we try to see if you're going to get the results. So it tells you the input range contains non-numeric data, because it shows that closing stock is not numeric. This is a text. So you have to tell Excel, yes, the first row is a labels. So after that, you come to the output options. So output option is about the results. Where do you want your results to be saved, or where do you want your results to be pasted? So in the first thing is the output range. So in this case, the output range is, do you want your results to be pasted within this sheet where the data is? If yes, you select where do you want it. I want my results to be here. I want my results to be here. I want my results to be posted from here. So if you don't want that, you say maybe, for example, I want my results to be within the same workbook, but in a different worksheet. Here we have sheet 1 and sheet 4. So maybe it can become sheet 2 or something of the sort. So you can say new worksheet apply. So new worksheet apply means that within the same workbook, but in a different worksheet. And again, we have option 3. Option 3 is where? Option 3 is new workbook. New workbook is, I don't want my results to be even in this workbook. I want it in a different Excel file. So we have this Excel file here, but I want it in a different Excel file. So that is the options that Excel gives you. But in our case, let us just say we want our results to be in the new worksheet. So if you have selected in the new worksheet, and let's just click OK. So these are our results. So, and what do our results mean? Say, let's say, for example, our significance levels, the significance level was 5%, which is 0.05. Or maybe we can say it is 10%, which is 0.1. So in this case, so this is what is going to help us to 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 make conclusions about our results. So the first important table is this ANOVA table, and this ANOVA table we run very fast to the significance f. Significance f is the p-value. This p-value at our p-value is 0.059. So in this case, you'll find that at 0.05, it is greater. So if this is greater than this, so definitely all our model has been rejected. So we can say that current asset ratio cannot predict closing stock. However, let's say, for example, our significance level was 10%, that is 0.1. You can see that our p-value of 0.059 is less than 0.1. So if it is less than 0.01, so we can say we accept this, we fail to reject our model, and we can say that our model is adequate. So let us assume that this is our our significance level. So let us start interpreting our results. So ANOVA, the first thing we have said that our model is adequate in explaining the current, in explaining the closing stock prices. So if it is, it's adequate. So we go to the next table. This is the next table here. This table just tells us how is the model performing. So the first thing is the R square. R square tells us the percentage of variation. So we can see that here we recorded 0.23. This is the same as if I put this here times 100, that is 23.17. So that is 23%. So 23% of the variation in the closing stock is explained by the model, or 23% of the variation of this of the closing stock is explained by our current asset ratio. So multiple R is just the correlation, and whereby if you square the correlation, you're going to get the R squared. So we come here to this final table. Our final table gives us the other result. So the intercept. First of all, the intercept is given. We are assuming that all factors constant. Let's say, for example, we didn't have the current asset ratio. What is our expected closing stock? If we don't have current asset ratio, the expected closing stock should be 55. And again, our p-value is significant. Remember, our significance level was 10%. And then we go to the current asset ratio. Our current asset ratio is negative 10.385. So what does it tell us? It tells us that a unit increase in the current asset ratio, it reduces, because it is negative here, the it reduces the closing stock by 10.38.